All right, pre-cal, we are still in Unit 7. So this is Unit 7, Topic 4. We are moving on to Topic 4 in this video. And we are going to be using our sum and difference identities. So on your identities handout, at the very bottom, we have sum and difference identities. And we are only going to use 4 of them. We are not going to talk about sum and difference for tangent. We've marked through those already. But we are going to use the sum and difference identities for cosine and sine. So if you will notice on your notes, I've embedded the identities right here. So that way we can reference them pretty easily. I've also got the unit circle over here. I've embedded it in the page for my video, but you are going to need to refer to it. So why do we need these, Miss Griggs? Well, sometimes I want to know something about a value that's not on the unit circle. Like, for instance, something like find cosine of 15 degrees. What would it equal? Now, I know we could plug it in the calculator and figure out what it equals, but this is a practice in using your sum and difference identities to manipulate this so that we can write it as an exact value rather than a decimal value. Okay, so find cosine 15. Well, 15 degrees, if you'll notice, is not on the unit circle. All right, if you look all the way around, all the way to 360, 15 degrees is not on there because 15 degrees would occur right there. So what do we do with this? Well, that's where your sum and difference identities come in because we have to use values on the unit circle in order to get this. So since 15 degrees is not on the unit circle, I need to use some values that do occur on the unit circle and either add them or subtract them, sum and difference identities, to get 15. Well, I'm no math genius, but adding two values to get you 15 is going to involve a negative and a positive. So I would go with subtraction here because it's probably pretty obvious to most of you that 45 minus 30 gives you 15. And both of those values occur on the unit circle. So I want to find values on the unit circle that either add or subtract to give me what I'm looking for. And that way I can rewrite it in an exact value. So I'm going to use a difference of 45 degrees and 30 because those values do occur on the unit circle. So what I'm doing is I'm using cosine of 45 minus 30 degrees because that's another way of writing cosine of 15 degrees. So basically I'm rewriting cosine of 15 degrees with values that occur on the unit circle. That's what I'm doing. So I want you to notice this is cosine and this is a difference. So I'm using this right here. I'm using this difference identity, cosine A minus B. All right, I put 45 first because 45 minus 30 gives me 15. So the A in the identity represents this value and this value. So whichever one's first, that's how it occurs. So because I'm using cosine of 45 minus 30, I want you to see something here. See, I'm using 45 and 30 here, so that means that's going to be 45, that's 30, that's 45, that's 30, because A is 45 and B is 30. So I am going to set this equal to cosine A, so cosine 45 degrees times cosine of 30 degrees plus sine of 45 degrees sine of 30 degrees. See how that works? Easy peasy. Now what I have to do is I'm going to use the unit circle. So use the unit circle now to replace cosine 45 with its value in the ordered pair. So at cosine 45 degrees, that's going to be radical 2 over 2. So I'm replacing this with radical 2 over 2. I'm replacing cosine 30 with this value, radical 3 over 2, plus Sine 45 is this, so radical 2 over 2. Sine 30 is 1/2. So now I'm just going to multiply these. So radical 2 times radical 3 is radical 6 over 4. And radical 2 times 1 is radical 2 over 4. So I can always write these as one fraction. Okay, so that's the exact answer of cosine 15. Could I find the decimal answer in my calculator? Absolutely, but that's not what we're doing. We're finding exact values from the unit circle. That is what we're doing. Okay, so that is just kind of an overview of topic 4. I'll do the other examples on another video.